Today we'll be talking about the Venn diagram. What is the Venn diagram? It is discovered by a man called John Venn. Please, for more on this, you need to subscribe to this channel. So the Venn diagram is a diagram that shows relationship between sets. It can also be called the set diagram. For example, the union of sets can be represented in the Venn diagram. The union of sets can be denoted as this. If this is set A and this is set B, the union of sets can be written in this form. And in set notation, the union of sets can be written in algebraic notation like this. X is an element of A, or X is an element of B, or both. So it's a set of all elements in A and in B, or both of them. The intersection of sets. The intersection of sets can be represented in the Venn diagram in this way. If this is A, this is set B. The intersection is the set or the element that is common to both A and B. So in set notation can be written in this form. X is such that X is an element of A and X is an element of B. We also have the difference of sets. The difference of sets A and B can be represented in the Venn diagram in this form. If this is A and this is B. So it can be represented in this form. A difference B is equal to X is such that X is an element of A and X is not an element of B. So this is how the difference of sets can be represented. We also have, and we put this sign here, difference of sets A and B. We also have the disjoint sets, which can also be represented on the Venn diagram. So the difference of sets can be represented in this form. This is our set A and this is our set B. It means that the disjoint set, which is A intersection B, is equal to an empty set. We also have the complements. Say the complement of set A, which is denoted in this form. So the complement of set A. The complement of set A can be represented in this form. The complement of set A can be represented in this form and can be written as A complement is equal to the universal set minus A. So this is how the complement of set A can be represented. So we take some questions concerning Venn diagram. For more on this, you can subscribe to this channel. We have a question here on Venn diagram. Use the Venn diagram to illustrate the information. This is the universal set. We have set A, set B, and set C. These are the elements in it. For more on set, you can subscribe to this channel. So the first thing we do is to draw the Venn diagram. Since we have three given items, we say let this be our A, this our B, and this our C. So this becomes our universal set. Now, let us look for this point first. This point is A intersection B intersection C. A intersection B intersection C, which is equal to, we now come here. What is the element that is common to both A, B, and C? Here, 2 is common. Only 2. So we have it as 2. These 2, we put it here. Now, A intersection B. A intersection B. That means the elements that are common to both A and B. We have 2 is common, 5 is common. So A intersection B is equal to 2 and 5. So in Venn diagram, since we already have 2 here, we are not writing 2 again, because we found out that our A intersection B, which is this point, is 2 and 5. So we only put 5 here, because we already have 2 here. Now, how about A intersection C, which is this point? A intersection C. A intersection C. A intersection C. We have 2 to be common here. Also have 4 to be common. So 2 and 4. 2 and 4 are common. Since we have 2 here, we'll only write 4. We are not repeating it again since there is 2 here. Now, we have B intersection C, which is this point. B intersection C. We have 1, we have 2, also have 6. B intersection C, we have 1, 2, and 6. This time, we already have 2 here. So we only write 1 and 6, since we already have 2 here. So the next thing to do is to fill up the empty spaces. Now, for A, we have A as 2, 4, 5, and 7. The set contained in A are 2, 4, 5, and 7. That means the elements contained in A. Here we have 2, 4, 5, but no 7. So we include that 7 here. We write that 7 here only. If we come to B, we have 1, 2, 5, 6, and 8. 1, 2, 5, 6, but no 8. So we write down that 8 here. If we come to C, we have 1, 2, 4, 6, 9. Already here we have 1, 2, 4, 6, but no 9. So we'll write that 9 here. In Venn diagram, you don't repeat any number that is already in the set. And if we watch out, we have 1, 2, 4, 5, 7, 8, and 9. A number is missing. Some numbers are missing. That is 3 and 10. That 3 and 10, we can put it anywhere around the universal set. So this is how to compute questions on Venn diagram. For more information, or for more on this, you need to subscribe to this channel to get more questions on Venn diagram.